going to go ahead and do a two-dimensional projectile problem. So what I'd encourage you to do, read the problem to yourself and do steps number 1 and 2 yourself. So pause this video, go ahead and do those, and then check back in, and I'll go ahead and do them here. Cool. So after you've drawn your picture, I'm going to draw my little picture here. So we have a good old football. I'm going to draw it right here. Here's my football. Do a nice little arrow. It is 35 degrees to the horizontal, 18 meters per second. And it's going to have beautiful little arch parabola. Cool. Awesome. So first thing that I want to do, draw a picture. Underline and write down what you want to find. So I'm going to look through kind of this problem, what I want to find. So I want to find how long it's in the air, horizontal range, speed. Cool. A lot of good fun things I want to find. Now, I drew my picture. Now I'm going to draw a coordinate system. So I'm always going to say the up and down direction is the y direction, and upwards direction is positive. And I'm going to say to the right direction is, horizontal direction is the x direction, and anything pointing to the right is going to be the positive. So now what I'm going to do is I'm going to split vectors into their x and y component. So I want you to think first before I answer, why do we need to split these vectors into their x and y components? So when I think about this, I think, okay, the only forces acting on this football once it's in the air is gravity. And we know that gravity only acts in the y direction. Gravity does not act in the x direction at all. If gravity acted in the x direction, as I'm sitting here in my chair, I would be pushed side to side, but that's not happening at all. So we're going to have to split vectors into their x and y components. So let me look right here. So I'm going to take this vector of 18, and I'm going to split that into the x and y components. So I know that Vx, so I need to do some solving, and Vy, I need to go ahead and solve. So I'm going to write down my good old Sohcahtoa, and you can do this yourself, but I'll go ahead and do it on here. So I encourage you again, pause the video, watch it later, or after you've done it yourself. So I'll find the x. It looks like that's going to be the adjacent hypotenuse. So I can set up cosine of 35 equals adjacent, which is Vx over 18. So now I do some fun old math. Vx is going to be 18 cosine of 35 degrees, which I plug into my handy dandy calculator, and I get 14.7 meters per second. Cool. Now let's do the same thing for the y. I'm going to have sine of 35 is going to be y because we have opposite Vy over hypotenuse, 18. So then Vy is going to be 18 sine of 35 degrees, which I plug into my handy dandy calculator, and I get 10.32 meters per second. So Vy I know is 10.32 meters per second. Cool. So now I'm going to go ahead. Actually, I'm just going to erase the stuff I did, so make sure you have that down. Cool. So let's go ahead and just guess what the speeds are of the football at certain points. So let's look at this highest point right here. Okay, so we know whenever something reaches its highest point, the velocity in the y direction is going to be 0 meters per second. That's the turning point. The x velocity right here, there's no forces acting on in the x direction, so that is always going to stay the same, and that is going to be 14.7 meters per second. Okay, so then at the top, the total speed would just be essentially a combination. We just essentially have to do the Pythagorean theorem, but y is just 0. So total speed at the top is just 14.7 meters per second. Cool, we just answered C. It is going to be 14.7 meters per second. Cool. So now let's look at the point right before it hits the ground. So right here, if it starts and ends at the same point, gravity is going to slow it down just as much as it speeds up. So the velocity is also going to be 18 meters per second, the total speed as it hits the ground. Now let's look at the x and the y. So the good old x velocity, we know again, no forces acting in the x direction. So the x speed, nothing is there to speed it up or slow it down, is going to be the same. While the y, I'm just going to move that over here a little too big. The y velocity, now it's going downwards, but it's going to go same speed but opposite direction. So that's going to be negative 10.32 meters per second. Cool. And we could also do that Pythagorean theorem with our y velocity and x velocity to prove that the total speed is 18 meters per second. But we just know total speed is 18 meters per second. Cool. So we're going to go ahead and look at A now. So just to tidy this up, I'm going to erase some other stuff that we have, but we'll look at A. Okay, so for A, we went ahead and we already drew our coordinate system splitting our vectors. Now let's choose 2 points to look at. So I want to find how long it takes until it reaches its highest point. So I'm going to go ahead and star or highlight my 2 points. Always make sure you're highlighting those 2 points, starring them, whatever you want. Cool. So we know that it is not just moving in just the x direction or just the y direction, it's moving in both directions. So I'm going to need to set up speed, distance, and time. And then for the y, vi, vf, a, delta x, and delta t. And again, what I want you to do is I want you to take a guess of what all the givens are, and then you can check back into the video after you've made a guess yourself. But it's super important that you have a guess yourself first. Cool. So after you've made a guess, let's go over what the correct answer is. So let's see. The initial velocity in the y direction is 10.32. That is that right there. Cool. Final velocity in the y direction, that is just 0 right here. We know acceleration is -10 meters per second squared. Gravity is pointing downwards. Time is what we want to find. Let's just fill out some givens for the x direction too. We know the speed in the x is 14.7 meters per second. Cool, and that looks like about all we know. And again, time we want to find. So I go ahead and look at where do we know more information, the x or the y? Well, it looks like we know a lot more in the y direction. So let's go ahead and pick a handy dandy constant acceleration equation to find time. So I'm going to choose that first good old equation. So we have Vf equals Vi plus A times delta t. So Vf is 0, Vi is 10.32 plus -10 times delta t. We do some fun little math. Take away 10.32 from both sides. -10 times delta t. Divide by -10. I love math. And then I get 1.03 seconds is our change in time. So that is going to be our time for it to reach the highest point. So I'm going to go ahead and put that in. Okay, so now let's go ahead and look at part B. So the horizontal range. So that is going to be, I'm going to use a fun new color, it's going to be our distance in the x direction. That is that distance right here. Okay, so to know that, now let's go ahead and find 2 new points. So now we're looking from this point right here to this point right here. Those are our 2 points that we're looking at. So it looks like that's a distance in the x direction. So I'm going to put my question mark here. We also need to figure out time. So what I want you to do first, think about how we're going to find time and then check back in. Okay, so it looks like the time we know to the highest point is 1.03 seconds. So, and again, this is symmetric. This is a parabola. So the total time is just going to be double that. So we know that 1.03 times 2 is what? 2.06 seconds? And that is the total time. Cool. So let me put that in there. So the total time is going to be 2.06 seconds. So now we just need to find the distance. So I know that speed is just distance over time. And again, it's not horizontal, it's not accelerating in the x direction because there's no forces or nothing pushing it in the x direction to make it speed up or slow down. So we have what? 14.7 equals distance over what? 2.06. And then I get the good old distance to be 30.28 meters. Awesome. Cool. And then we got our answer for B, which is 30.28 meters. Awesome. Thank you for watching.